Hello and welcome to the Spinal Cord Injury Forum. I am Stephen Burns, Medical Co-Director of the Northwest Regional Spinal Cord Injury System. The forums, the video recordings, and our online media content are made possible by a grant from the National Institute on Disability and Rehabilitation Research. Tonight we are pleased to have Dr. John Steeves presenting a talk entitled Survive, Subsist, Succeed, Spinal Cord Injury Outcomes. Dr. Steeves is the founder and director of ICORD, the international collaboration on repair discoveries at the Blossom Spinal Cord Center in Vancouver, British Columbia, and professor of zoology, surgery, and cellular and physiological sciences at University of British Columbia and Vancouver Coastal Health. There will be times for questions after the presentation. Now please welcome Dr. John Steeves.
Well, first of all, let me say how pleased I am to be back in Seattle. It's so nice to be able to give a lecture so close to home. And it's great to be here. I'd like to thank Stephen for the invitation, as well as Chuck, Jeannie, Katya, Steve Steins, as well as Debbie for a wonderful time at dinner tonight. I know this is being filmed. I think it just makes it a little bit more interesting. If you take the opportunity to interrupt me whenever you want to discuss something, it may take a little bit longer to get through it, but that's okay. We have a couple of hours. So if you want to ask a question or make a comment, please don't hesitate to do so, and just be a little bit loud in case I don't see you waving your hand or I don't hear you. I'd also like to introduce Dr. Pat Wall, who has joined us tonight. For those of you who don't know Pat Wall is a professor at the University of Miami. He's one of the leading researchers, basic scientists working on spinal cord injury. And he and his colleagues at the University of Miami are about to embark on a clinical trial, which I won't be talking about tonight because it hasn't started yet, which will involve the use of Schwann cells as a bridge for promoting repair after spinal cord injury. As I said, that is yet to start in this acute care treatment, but it's nice to see you again, Pat. So, as indicated by Stephen earlier on in the introduction, there is this document that provides you with some information with regards to experimental treatments for spinal cord injury. It is available at the ICORD website. And for all of you who do not care to listen to anything else for the rest of the evening, all you have to do now is copy down the website address and you can go to sleep. So probably the most interesting part of this document when we drafted it a few years ago, and yes, I do need to revise it and update it now, and I will be doing that this summer. The interesting part is that we do provide you questions that you should ask of anyone who's offering you an experimental treatment. And we even provide you some answers that should be forthcoming when you ask those kinds of questions from anyone who's offering you a treatment. It's available in multiple languages, and as I said, we will be updating it shortly. So that's all you have to remember is the website. So here is an ancient scroll. This comes from about 1700 BC. It's been ascribed to Imhotep. Now, for those of you who like going to movies, including the movie called The Mummy, Imhotep is not the bad guy in the movies. Imhotep was actually a physician in ancient Egypt, and he is thought to have contributed, amongst other people, to this particular document, which was discovered in 1862 and is known as the Smith Papyrus. And it does describe spinal cord injuries, and as you can see, there wasn't much optimism in ancient Egypt with regards to treating spinal cord injuries. And that persisted for quite some time. In the First World War, which of course happened not too long ago, about 100 years ago now, 80% of the patients who survived the initial primary trauma died of UTIs, urinary tract infections, and many of the rest died of pressure sores. So the outlook was not that great. In fact, survival was the key back at the turn of the 20th century. However, throughout the latter years after the war, several groups, including Donald Monroe at Harvard and Boston City Hospital, established specific spinal cord injury units. These were also established in the United Kingdom as well as in Canada at about the same time. And the whole effort there were made for bladder care and prevention of pressure sores, which, as I said, were the primary causes of death in people with spinal cord injury. And as you can see, through this sort of very careful and assiduous efforts of Donald Munro and his colleagues, they were able to reduce mortality. And now we move on to the Second World War, where we're starting to move into not just surviving, but perhaps subsisting, getting back some part of your life. And after the Second World War, and I should say during the Second World War, towards the latter stages, a hospital was set up in the United Kingdom, and it's referred to as the Stoke Mandeville Hospital. It really wasn't that fancy a hospital, and in fact, it was made up of old army huts, or Quonset huts as they're referred to. And even today, some 60, 70 years later, you can still find some of these Quonset huts at the Stoke Mandeville Hospital. And it was a German refugee, Jewish refugee from Germany, who came over in the 30s, who set up this hospital, and his name was Ludwig Gutman. And not only was he like Donald Munro and several others in terms of trying to set up better care of people with spinal cord injuries, he was also the person to introduce sport. And he created what is called the Stoke Mandeville Games, which are today's Paralympics. So we have Ludwig Gutman to thank for the inclusion of disabled athletes in the Olympic movement. In the more recent times, of course, we've moved on from subsisting to succeeding and integrating back into the community. This happens to be a picture of one of the Canadian Olympic basketball players. His name is Jamie Borissov. He happens to be one of my former trainees who got his doctorate with me in Vancouver, but was also a double gold medalist at the Paralympics, and currently has his own research lab where he works on assistive devices. And Jamie actually has been very instrumental in designing some of the world's most accessible and innovative wheelchairs. And if you are ever looking for a specialized purpose wheelchair, Jamie's the guy to talk to. So what are the priorities of people living with spinal cord injury? Well, they vary, and they vary dependent upon the time since injury, the severity or level of injury, your ongoing challenges to live with a spinal cord injury. Obviously, there are a myriad of reasons that will affect your priorities as you move on with life after a spinal cord injury. And as I said, they depend on time. And so if you look early after spinal cord injury and ask people with tetraplegic injuries what are their priorities, you'll see this kind of a list in terms of high priority, second, and third priority. And the interesting thing here is to notice that walking is something that everybody wants immediately after a spinal cord injury. Sometime later, perhaps a year later, you'll see that those priorities start to shift. Arm and hand function for tetraplegics is still very important, but now sexual health and sexual functions become much more important. Trunk stability is also now moved up in terms of priority. I haven't got it on here, but walking, as would be somewhat understandable, has fallen way off the list of a priority. For those of you who are concerned or interested about paraplegic priorities, the number one function, both early and late after spinal cord injury, is sexual function. So even walking for paraplegics is a lower priority than sexual health. And all this data, as you see here, comes from a survey that Kim Anderson did. And Kim Anderson is a researcher who is a tetraplegic. She was working at the University of California at Irvine, but is now currently working at the University of Miami and the Miami Project to Cure Paralysis. So in terms of talking about sexual function, this is probably one area of success that we have met with over the last few decades, both in terms of enhancing sexual health, enhancing sexual function through a variety of different developments and drugs, as well as coming up with ways to harvest sperm and use in vitro fertilization so that people with spinal cord injuries can also become parents. In Vancouver alone, we have over 125 people who have children born to them from our efforts at ICORD. So as we said, there's a long list of ongoing challenges that everyone has to face after a spinal cord injury, and to varying degrees, people have had to meet these challenges. And the developments that you see here in terms of how these particular challenges might be treated, not cured, but treated, has grown tremendously. And in fact, most of these advances that you're seeing listed up here have happened within the last, I'd say, 10 to 15 years. So there has been a huge success in terms of what you can now live with and what you can now utilize to become an independent member of your local communities. There's been a number of alternative medicine treatments proposed for some of these medical challenges, including such things as hyperbaric oxygen, vibration therapy, and acupuncture. I get questions a lot about hyperbaric oxygen, which is really breathing pure 100% oxygen. Normal air, of course, is only 20% oxygen. And it comes at a very high pressure, up to 3 atmospheres, which means 3 times the normal pressure that you and I are experiencing right now. Unfortunately, there's no statistical differences in terms of proving outcomes for people with spinal cord injury. However, that being said, there have been benefits shown for skin lesions and pressure sores, and this is true of both the able-bodied and disabled communities. So hyperbaric oxygen has its uses, but in terms of reversing any damage that's been done to the spinal cord, as yet there is no evidence. Vibration therapy has been suggested, and I don't know, how many of you have tried a vibration platform? Anybody here? Stephen and I have. It rattles your teeth, doesn't it? Yeah. So you can stand on there and you can get a real good rock and roll thing going there. It's, you know, a lot faster than the 50s. However, once again, this particular type of therapy has been sort of directed to increasing bone density. As many of you will know, that the conditions of osteoporosis after spinal cord injury are something that is a concern. So if one can increase mineral density, bone density with vibration therapy, or increase muscle mass, then obviously it is having some benefits. Once again, though, in terms of looking at this kind of very expensive piece of machinery, if you were to use more conventional exercises, you'd probably get the same benefits as you would with vibration therapy. Acupuncture, none of us know how this works. It's been around for thousands of years. There are people who will swear by it. And it clearly has benefits in terms of people reporting wellness, whether they have a disability or not. It's been used as a form of anesthesia. It's been used for a variety of different things. If it works for you, great, because the adverse events or side effects, harmful side effects that might happen due to acupuncture or electroacupuncture are very minimal. So it all depends on your particular persuasion as to whether it provides you some benefit. Some people swear by it in terms of reducing pain and making them feel a heck of a lot better, and that's great. So now a lot of you are probably thinking, well, are the research priorities of people living with spinal cord injury matched with those of the researchers? And the short answer is sometimes yes, sometimes no. But more recently, the multidisciplinary collaborations that have been established in such centers as ICORD in Vancouver and the Miami Project in Miami and several other jurisdictions throughout the world are allowing people from a variety of different backgrounds with different experiences to come together on a specific target, a specific research target, bringing all the wealth of information that they have from their particular perspective to match up with those of different kinds of backgrounds so that we can bring greater insight and greater and faster development of innovative devices and treatments to improve outcomes. So the answer is that there is a big effort underway now throughout the world to improve outcomes and indeed the priorities of people living with spinal cord and traumatic brain injuries and other neurological disorders is indeed very, very similar to the efforts of the researchers. So where are we going to get these developments from? Well, fundamental biology is incredibly important to our understanding not only how the spinal cord functions, but as well to understand the pathology that happens after a spinal cord injury. So there's a lot more research that's needed. However, there's another big thing that a lot of us are focused on, including myself and Stephen in collaboration with many other people from across the globe, and that is how do we translate it? How do you take a discovery and take it through to a clinical trial in a valid manner? How do you do it effectively so that you can get a clear, clean answer? Does it work or does it not work? The last thing that we want to have is, of course, any harm brought to anyone who's in an experimental clinical trial, but we also don't want to end up with an answer that is nebulous. In other words, we don't understand what the outcome was, or we can point to a lot of shortcomings in the way that we conducted that clinical trial. So translation of research has become a big issue. It's not an issue that's specific to spinal cord injury. We're having a hell of a time in terms of translating any kinds of discoveries these days. And in fact, the FDA has been licensing a very small number of drugs over the last few years. And most of the clinical trials are failing. So it doesn't have to do just with spinal cord injury. They're failing in stroke. They're failing in Parkinson's disease. They're failing all over the place. So we need to come up with better research and better ways of translating that to human outcomes. So in reviewing what is currently available, this is something that all of you who've had a spinal cord injury have experienced undoubtedly in your past. You've had various sort of treatments at the acute stage in terms of traction, surgical decompression, and spine instrumentation to stabilize the spinal column so that there's no further damage. There's an ongoing study by a multinational group of surgeons, spine surgeons, looking at timing of spinal surgery to decompress any pressure on the cord or to stabilize the spinal column. And they're suggesting that the earlier that this is done, the better the outcome. Now, for many of you, of course, this is something that's in the past, but I want you to understand that there are efforts underway in terms of both acute and chronic treatments, and that will be the basis of the rest of my talk. In terms of some of the subacute and chronic strategies that have been employed to improve outcomes, most of them that have been recognized as being effective are those that deal with physical and occupational therapies. And they come in a variety of different forms. We'll be showing you some of these things throughout today's lecture, but they include such things as weight-supported treadmill training, as well as what's called constraint use therapy. This is something that came from the stroke field, people with stroke, and it really involves taking a particular arm and training that particular arm that may have more deficits in terms of function, so that you only use that arm to regain and recover better mobility, range of motion, and function with the hand. We'll talk about those a little bit later. I don't have time to go through all this. These are just some of the things that the basic scientists are focusing on. And as you will see, the spinal cord is a very complex piece of tissue in your body, and there's a number of different elements that make up the spinal cord, and there are a number of different mechanisms that are involved in the development of the spinal cord as well as maintaining its proper functions. And when these things are damaged, these are some of the targets that basic scientists are trying to focus on in terms of developing new treatments to either limit the damage that happens immediately after a spinal cord injury, or develop therapies that might promote repair subsequent to that injury. So I won't specifically talk about some of these, but undoubtedly you have read about some of these things, and if you'd like to ask me about them, I'd be happy to talk to you about them. My background is not just working with people with spinal cord injuries, it's also as a basic scientist. So I actually did a lot of this type of work in my past. When we look at timing, what are we trying to achieve in terms of repair? Well, in an acute situation, we're really looking to protect the cord. So what do I mean by that? You're sitting there saying, well, what the hell happened? I mean, it's been damaged. I mean, how can you protect something that's been damaged? Well, most spinal cord injuries do not sever the cord completely. And in fact, most people, as you know, have a spinal cord injury. It's very similar in some respects to a bruise, and so it causes some damage to the cross-sectional area of the cord, but it doesn't damage all the cord. But what does happen, just like in a bruise when you bang your elbow, is that there is these secondary mechanisms that cause the spread of the pathology to a wider region of the spinal cord. It's these secondary cell death type mechanisms, these inflammatory immune responses, that we can target as ways of limiting the amount of spinal cord damage that occurs after the primary mechanical trauma. And if we can target these secondary events, that will preserve more intact spinal cord and therefore obviously bring about enhanced improvement thereafter. So protection is something that gets targeted within the first few days to few weeks after injury. Then we move on to repair and regeneration. Repair is a very complex process. You're all aware of neurons having axons and you want them to regrow or regenerate. That is only one aspect of repair that we have to control after a spinal cord has been injured. We need to look after a variety of different types of cells within the spinal cord so that they all work in concert with each other to bring about the most effective functional outcomes. So repair and regeneration, we estimate, can go on for weeks to months. We don't know the exact time limits on this, mainly because we haven't had enough experience with humans in clinical trials to know what are the windows of opportunity. And then we have something that we've called here recovery. And you're going to see this word crop up. And for those of you over on the right-hand side of the room, the word is plasticity. And I'll be coming back and talking a little bit about that because it's fundamental to repair processes and recovery processes after spinal cord injury. Now, recovery is a lifelong process. It's something that all of us are involved with, as you will see a little bit later on. As we age naturally, we're going through plasticity. As we develop from children into adults, we're dealing with plasticity. There's a variety of different mechanisms that we can talk about. But why most of you are probably here is to talk about cell transplantation. That's what everybody wants to hear about. And you know that transplanted cells are being offered by overseas clinics, but they're not being offered here in North America. And you're probably asking yourself, well, why is that? Are we so backward here in North America that we can't figure out how to do cell transplantation? The short answer is no. But by the same token, we don't do things in North America and for most of the developed world that hasn't been validated as being beneficial for patients. So let's just look at the situation that we have to deal with. First of all, let me tell you that transplantation of cells will be effective in the future. It will first be effective for very targeted pathologies and very targeted repair processes. And we can talk a little bit about that in a bit. The second thing is to tell you is that cell transplantation works very well for very simple tissues of the body, including bone, skeletal muscle, even cardiac muscle of your heart. So there is a lot of advances being made in this, and there are a lot of advances being made in the basic science of cell transplantation into the most complex organ of your body, which is, of course, the brain and the spinal cord, which has about, we guesstimate, and it's a guesstimate, approximately 100 billion cells. Okay? So we have about 7 billion people on the planet, and you can multiply that by almost 14 times, and you will end up with how many cells are in your brain. By the way, your body contains trillions of cells. And there's 100,000 different cell types. So I told you that bone was someplace that cell transplants were actually being beneficial. Bone has about 6 different cell types. 6. Not 100,000, 6. So you can see that once again, bone is a very sort of simple tissue. It's structurally very simple as well. So we know that stem cells can be pushed, as it says here. We have very fancy names for this, but we'll just keep it simple. We can push stem cells to become different types of cells in the body. But one stem cell, or one type of progenitor cell, as we sometimes refer to these cells, cannot be pushed to become thousands of different cells. So it has limitations, all right? And if you have 100,000, well, then how many stem cells are we going to need? Can we push them to become 100 different types of cells? Even if it's 100, we still need 1,000 different types of stem cells. So you can see the magnitude of the problem is not trivial. So except for a few cell lines, and Pat Wall, who I mentioned at the beginning of this talk, has been involved in one of these types of cells, the evidence for benefit after even animal spinal cord injury has not been reliably achieved. So we're not successful in a reproducible fashion, even in animal models, using cell transplant strategies. So there's a lot more for us to learn. Now, for those of you who are thinking about this, I don't want you to be disappointed or depressed. There's a lot of things that you can do, which we're going to finish up the lecture with, that are very positive. But we need to have not only better basic science on stem cells, we also need to have objective clinical trials, as I said, translate that discovery in a valid way to show that it is a good clinical practice. So why are these things still going on overseas? Well, let me tell you why. First of all, let's call a spade a spade. The ethical principles being used in some of these countries is not the same standards that we apply in North America or Europe or Australia or parts of developed Asia. The other thing I can tell you about transplantation of cells is I can teach every one of you here how to do cell transplantation in about 3 weeks. Okay? Now you can't do it well, but that's not important here, okay? So learning how to grow cells in a dish is child's play. It's very, very easy. We teach undergraduate students, we teach high school students how to do this. So this is something that any clinic anywhere in the world, by and large, can do easily, if not badly, all right? So that by itself is something why they get into it. This is something they can do. You don't see them doing gene therapy, okay? That's very difficult, all right? And that's even difficult for us to do in our very advanced labs. But cell transplantation, growing up cells in dishes, let's not even worry about whether they're really stem cells. They're just cells growing in a dish. And we'll tell you they're stem cells, and then we'll put them into you, and voila. So it's very easy for these people to do this kind of stuff. The other thing, and this is really a bonus, and this is something that Pat and I, you know, being senior, can I say that, Pat? Pat and I being senior people, when we went to school, we were told that the brain and the spinal cord was a place that if you put something into it, it would do really bad things. Because your brain and your spinal cord did not have the ability to defend itself against any foreign object being put into it. Well, that turns out to probably not be true. You can put all kinds of things into the spinal cord, and it won't kill anyone, okay? So people survive these cell transplant treatments very well, thank you. And in fact, they get told to come back and pay more money to have a second treatment, you know, and you can keep doing this until finally people get smart. So that's another reason why these things are continuously being offered. People don't die, therefore the liability of being sued is minimal. Thank God, they're saying. I can now pay for the swimming pool in the backyard. And they can do this technology relatively inexpensively. Now, everybody that you probably have seen who's had a testimonial on the web has talked about the benefits of cell transplantation. And you have to ask yourself, can I believe them? Or can you? So what happens to anybody that goes in for a medical treatment, any kind of surgery for that matter, in any hospital, when they come out of anesthetic and they're in the recovery room and you say, how are you feeling? Oh, I'm feeling much better. That's always the answer. I mean, everybody wants to please everybody. Nobody wants to say, oh, I'm feeling really shitty. Thank you very much. No, they always will report positive results. People want to please, and if somebody has made an effort to do something on your behalf, even if you've paid for it, you're going to say, yes, I feel better. Okay, let's also think about the fact that these are very expensive treatments. They're charging you a lot of money. So what have you done? You've remortgaged the house. That wasn't enough money, so we're going to have some fundraisers. Well, let's get the community involved. So the community gets involved, and they pile up lots of money, and they put you on a plane, they send you over to China or India, and you get the cell transplant treatment. You come back, and there's a big welcome home party. What are you going to tell your neighbors? Well, that would be an honest answer, and probably an appropriate answer if you said, I feel like crap or nothing has happened. But usually we'll say, oh, I feel much better, because once again, we all want to please people. That's what humans are like. We want to please people. So patient reports, self-reports, is a well-known placebo effect. It's why in clinical trials we can't rely on patient reports as our final outcome. All right, because everybody wants to please. It's not objective, which is why we have repeated trials with randomized control groups. We have blinded assessments, so people come in and measure the benefit or lack thereof, who have no idea if this person's a control person or an experimental person. And that gives you some objectivity. And we don't accept payment. A clinical trial never charges a subject in that trial, a participant, for any payment for that trial. So when we do clinical trials, none of us get paid. It's strictly something that would bias our results. So anytime somebody wants to charge you for something, it's not a clinical trial. So going back to the kinds of treatments that have been used, here's a treatment that came to us from a number of clinical trials done in the 1980s. It's called methylprednisolone. This is an anti-inflammatory. It's a corticosteroid. How many of you here had methylprednisolone after your spinal cord injury? A few people, all right. Some of you probably don't know, and that's fine too. So this particular corticosteroid, because of its anti-inflammatory, in other words, it reduces swelling activities, was thought to improve outcomes. It never quite reached statistical significance. But because people were desperate to provide something for patients, and because it was relatively safe, people started providing it. Now, it turns out, of course, that there are some side effects of giving fairly large doses of corticosteroids or anti-inflammatories to anybody, including somebody who's totally healthy. The first thing, of course, is that it can reduce your immune responses to any kind of infection. So this is, a somewhat serious side effect if you have too much corticosteroids on board. The benefits of corticosteroid treatment are not what we call substantial. They're modest at best. But because of a lack of anything else at the time, various clinics and hospitals throughout the world continue to use it. And we'll see an ironic, if you like irony, an ironic example a little bit later in the talk out of Italy. Well, here's some other particular drugs and treatments that have been tried over the years. Here's one called Sigen. Don't really worry about what this drug does. We actually don't know. But we don't know what aspirin does either. And we still use that one. But GM1, or as its trade name was called Sigen, was a very large clinical trial. It was incredibly well done. Once again, this particular drug did not achieve any statistical significance from the control group, but Stephen and I and dozens of other people have used this data coming out of this trial as our background for other trials ever since then. There's another one that is called GK11, and this is also another neuroprotective. This one was done in France, and this is a remarkable trial, once again very large. They didn't ask for consent. Now, when we do trials over here, we have to get your informed consent, which means we have to explain everything to you, you have to understand it, and you have to agree to participate. In France, we're French, we don't have to do that. We have community consent. And community consent means that as you're lying unconscious by the roadside after a vehicle crash, we're going to pick you up, put you in the ambulance, and we're going to give you GK11 right away. And you don't have any ifs, ands, or buts about it. The community has decided this is in your best interests. So makes it real easy to do a clinical trial because you dispense with the whole idea of ever talking to the patient. However, once again, it didn't achieve any significance in terms of outcomes, except for one very small group, and they're trying to get funding to start up that group again in terms of its outcomes. Fampridine, foraminopyridine, this comes from a company called Accorda out of New York. It has been licensed for use for multiple sclerosis. It just missed statistical significance for spinal cord injury. It's a chronic treatment, so that means it would be available to some of you in this room if you were eligible with the right criteria. There is talk about trying to start up a new trial with this drug, once again with spinal cord injury, because they've learned a few things about this drug since they did the last trial, so it may come on board. Here's one cell transplantation approach. You've got a type of cell in your bloodstream. It's called a macrophage. It's a white blood cell. It's a cell that gets rid of foreign objects. So any kind of foreign cells, dirt, bacteria, macrophages will eat this little foreign object and they'll remove it from your body. Somebody came up with the idea, and I won't go through all the history of it, that if you use macrophages, they would have a benefit for spinal cord injuries. It's not been published yet, but I can tell you because it is public knowledge now. They did 44 patients with this kind of treatment within 14 days of their spinal cord injury. The experimental group did worse than the control group. So this particular cell transplantation approach actually had detrimental outcomes. And that's an important point for you to realize, is when you go into any kind of a clinical treatment, you are getting the best standard of care, all right? And people sometimes say, well, I don't want to be part of the control group. I want to be in the experimental group because I'm going to get better. Well, no, sometimes you can get worse. All right, nobody died. I don't want you to think really dark thoughts. But these people did not recover spontaneously. They didn't recover as well as those people in the control group which didn't have the cells. So they recovered much better. So that's something to look into. Now we're going to come back to these activity-dependent trials. This is the spinal cord injury locomotor training trial for those of you over on this side. This is the body weight supported treadmill training. And this has been shown to be very beneficial in terms of those folks who have an incomplete spinal cord injury. In other words, preservation of some sensory and motor function, especially below the level of initial injury. Bruce, do you mind me mentioning? Thank you. Bruce Hansen, over here, who's probably known to many of you, from Seattle, is now in Asia D. Bruce went through extensive body weight supported treadmill training and recovered a lot of function, and now, of course, walks independently with the use of one cane. So this kind of active rehabilitation indeed does work, and it works for particular types of functions, and it works for those folks who have some preservation of motor function below the initial level of injury. So we've learned a lot from these past trials. It wasn't a waste of time. It wasn't something that should be ignored or thrown away. We've learned a lot about what we need to develop in terms of how to do trials more effectively, and that's something that you can read in those notes that have been handed out to you. So now what I'd like you to do is just sort of look at your thumb. Now, if you can do what I'm doing, sorry. So what Chuck's focusing on is this is a particular type of enhanced activity-dependent training that mainly focuses on walking. Now, there's a variety of different kinds of rehabilitation that you've all undergone at various points after your spinal cord injury, and they all had specific targets or goals in terms of improving function. And what Chuck is focusing on right now is the fact that the control group here wasn't left to just sit there and do nothing. Instead, they were given enhanced physical therapy of a variety of different kinds of activities instead of body weight support treadmill training, which was left out. Both groups did well. The point I want to emphasize here, though, is that activity-dependent rehabilitation, not passive massage, that's nice, very nice. But activity-dependent, when you have to do something to participate in your own rehabilitation, that is critical in terms of improving outcomes. And we'll talk a little bit, as I said, that's what I'm going to finish up with a little bit later on. Is that okay? Okay. So where are we? All right, thumbs. All right, first of all, how many of you have thumbs like this? Okay, now if you have a thumb like this, you're in deep trouble. See, I have a thumb that can bend over 90 degrees. Now, has anybody else got a thumb like that? All right, Kate has one. All right. All right, so I want you to look at that distal part of your thumb, that little part that you can move. That's the goal for achieving a functional clinical benefit. That distance is what we want to try to achieve after your spinal cord injury. Because that small distance can bring about significant and dramatic effects in terms of not only your function, but your independence, your mobility, and your quality of life. And this is just one example. And Stephen or myself or any of the other physicians who are here in the room with us today could go through a number of different examples. This one happens to come from somebody who's had the 4th cervical segment of their cord damaged in comparison to somebody who's had the 6th cervical segment of their cord damaged. And what you're seeing in blue, and we're just going to focus on the left-hand side, is those activities of everyday life that they can partake in independently with no assistance. So here we have a C4 independent list of activities. They can talk, they can swallow, and they can breathe. That's it. However, if that recovery was brought down 2 segments, distance of your thumb, these are all the activities that they can engage in independently. And as you can see, that kind of achievement in terms of functional recovery or repair would dramatically change that person's ability to independently partake in a wide number of activities within their community, including being independent in terms of their mobility and getting a career started again. And that's just but one example of why we're not looking to repair over that distance. That's not necessary. And you'll see why once again towards the end of the lecture. The other thing I'd like you to focus on, and this comes from some unpublished work that Stephen, myself, and others have been doing over the years, is to look at the process of natural recovery. Many of you had an injury. You were told that it was, okay, a T8 injury, thoracic 8 segment. It was a C4 injury. It was a C7. Whatever the case, the level of injury. The reality is that you will recover, about 3/4 of you will recover 1 segment of spinal cord function spontaneously. So remember, I said 2 segments is really going to change your life. 1 segment is likely to come spontaneously without much effort by many of us. And that's just the way the numbers work out. So we're really trying to push even for that 2nd segment. So now you can take that goal that we're trying to achieve and you can knock it down to your thumbnail. That's the distance we're trying to get. If we can recover that, we're going to bring about a real difference in people's lives. So now I'm going to turn to some of the trials that are being done or planned for the next couple of years in spinal cord injury. The first one is a somewhat surprising sort of drug to suggest for therapeutic use in spinal cord injury, and that's lithium. It's a classic drug that's been used for decades for a variety of psychiatric illnesses, including bipolar disorders. But it's now suggested to provide neuroprotection. This particular drug is being championed by a guy by the name of Wise Young. And Wise Young is probably known to many of you from his SCI info pages and his SCI forum. Wise is coordinating a group of hospitals in the People's Republic of China to undertake this particular trial. And once they complete that trial, they'd then like to move on to a cell transplant trial where they're going to use umbilical cord cells, which we can talk about if you'd like a little bit later. But I want to emphasize that this hasn't really gone into clinical trial. They're still trying to raise money over in the People's Republic of China to do this trial. There's another drug. This is called Riluzole. This drug has been approved and used for years for amyotrophic lateral sclerosis. That's a mouthful, sometimes referred to as ALS. And in the United States, it's often referred to as Lou Gehrig's disease, because this is indeed what Lou Gehrig died of. It's a progressive pathology, neuropathy of motor neurons, and it leads to respiratory depression and ultimately respiratory paralysis. So this particular drug was approved for this particular disorder, ALS, because it prolonged life. And once again, it's a neuroprotectant. It's well known in terms of its dosing, what side effects might happen. So it's a well-known clinical drug, and now there is plans to start up this particular trial and investigate the use of Riluzole, once again for acute spinal cord injury across Canada and the United States. So here we come to Italy. So here's a drug that you've probably heard about. And you're probably sitting there saying, where have I heard this stuff before? EPO. So how many of you know what EPO has been used for? Who likes to use EPO in sports? There we go. The right answer, cyclists. So EPO can actually boost the delivery of oxygen throughout your body. So it delivers an enhanced oxygen carrying capacity of your red blood cells. But we won't get into all that stuff. I mean, even though it's a banned substance, and of course you can get booted out of any sport if you test for too much EPO in your system. It's also been promoted by a bunch of Italian researchers as a possible neuroprotectant. But you'll see here that it's contraindicated with methylprednisolone. Now, I want to emphasize that this is a controversial drug. In animal models, people have been trying EPO, and some say, hey, it works great. Other people say, I don't see a damn thing. Doesn't work at all. So that's kind of controversial. We don't know. But the one thing that everybody agrees on is if you give EPO at the same time as you give the corticosteroid, they'll cancel each other, okay? So, I mean, all right? All right, now, next question. Where's the one country in the world where it's absolutely mandated by law that you be given methylprednisolone by the paramedics in the ambulance after a suspected spinal cord injury? The answer to that question would be Italy. And indeed, they have started a trial, but they have had difficulty recruiting people to participate in that trial because everybody, when they arrive at the hospital, has already had methylprednisolone. How's that for irony? So, even the best laid plans in terms of trying to do a clinical trial can be offset by some unintended consequence of science. What is the connection between acne and spinal cord injury? Well, there's another anti-inflammatory drug that's been used. The window of opportunity seems to be a bit longer. It can last and potentially have beneficial effects for several weeks after spinal cord injury. This drug is known as minocycline, and this is a trial that has been started in Canada and has been ongoing for a couple of years out of the University of Calgary It now has participation from several other centers in Canada. I don't know the results. And that's a good thing that I don't know the results, because it means all the assessments have been done in a blinded, objective fashion. All I can tell you is they've been trying this drug to see if it promotes better recovery against control subjects that don't get the drug, and they've kept all the results blinded, as they should, until they've completed the trial. But nevertheless, this drug was first developed for stopping acne. So that's the link between acne and spinal cord injury. Now here's a drug. Now we go from, small investigator, hospital-driven trials, and now we go to big pharma. So here's a trial that's underway by Novartis. Now for those of you who don't know who Novartis is, they are a Swiss-based pharmaceutical company. They're the third largest pharmaceutical company in the world. They're worth billions. Okay, they're bigger than Microsoft. Okay, that's how big they are. So they're not a trivial company. So they have taken a discovery made most popularly by a Swiss scientist by the name of Martin Schwab, and he's discovered a protein that exists within myelin. Now, for those of you who don't know much about myelin, there's this other cell type in your spinal cord that makes this sort of fatty substance that wraps around the axons of each neuron as they project up and down the spinal cord. And it wraps around in a jelly roll fashion. You know what a jelly roll is like, right? Just over and over and over again. So within that myelin are proteins that by and large will put the brakes on any axonal growth. This actually makes sense after you finish development. I mean, you go through development, you grow up to a certain size. You have a head of a certain size. You have a brain that you want to keep at a certain size. The last thing you want is a brain that's out to there. So, as we're completing development, we say, does everything work? Do all the connections work? And if the answer is yes, we wrap it up in myelin. It's like packaging. And it's great. So, myelin acts as a stop signal for any further growth in any gargantuan sort of way. But if you have a spinal cord or brain injury, well then myelin is sort of going to put the brakes on any kind of repair process. So they came up with an antibody. And antibodies block proteins, and this antibody is called no-go. And they've come up with a human form of this, and they're now doing a phase 2 clinical trial. They've gone through the safety trials. This is being done in Europe. They would like to come to the United States and Canada. They're trying to get approval from the regulatory agencies of both countries to come here and do this trial. But this is big pharma, who have billions of dollars, and they've already invested probably $250 million in this drug alone. So it takes a lot of money to get new therapies through. Here's another one that came from science. This one you're going to love. There's one part of your brain that we've known to be able to grow for decades. So you can all go and breathe in. And hopefully it's not too bad when you breathe in, okay? The person beside you has used a deodorant, which is good. Everything's fine. All right. Those odor receptors in your nose, they only last for a few months, and then they die. And so normally, if you didn't replace those odor receptors, you would lose your ability to smell anything after a few months of life. Kind of boring. Can't taste, can't smell. So your body, like just about all animals' bodies, continues to make these receptors throughout your entire adult life. Okay, that's good. We've got receptors for these things. But they have to connect with the brain so that you know what the coffee smells like, right? Especially if you're in Seattle. You've got to know what coffee smells like. So, people have looked at this ability for these olfactory receptors and these olfactory neurons from your nose, inside your nose, please, no picking, to grow back into your brain, and this happens continuously. there's a supporting cell that guides these axons back into your brain. It's called an olfactory ensheathing glial cell, or OEG. Okay, so somebody came up with a bright idea. Why don't we take these cells, put them into a damaged part of the nervous system, and see if they'll support the growth of all kinds of neurons? So that's the idea. So the Australians, bless their hearts, scraped together a few $1 million and did 6 patients. They did 3 experimentals and 3 controls, and they took the patient's own olfactory neurons and their own olfactory and sheathing glial cells. You've got 2 nostrils, just like 2 kidneys. Only need 1. So they took the olfactory and sheathing glial cells from one of the nostrils. They grew them up in cell culture, like I said. High school students can do this. And they put it back into the spinal cord of patients who'd had a spinal cord injury for at least 1 year, if not longer. Unfortunately, all the patients survived, but none of them showed any improvement whatsoever. Now, it could be that one has to do this at an earlier time point. Waiting 1 year is waiting too long. We don't know the outcome of that particular trial because the Australians have not been able to raise enough money to do it at an earlier time point. In other words, to do another clinical trial. Admittedly, this is a very small sample size. But there's been a number of efforts to sort of look at some of these supporting cells. And this is another stem cell. Like I said, things are coming through. They're coming through for specific purposes. So this particular stem cell that's being proposed here is a cell that makes up the myelin that I just talked about. And as I said, myelin can be bad for regrowth. It's another thing that myelin can be bad for, though, if it disappears. If myelin disappears, the conduction of action potentials, of neuronal activity, of excitation along that axon is also blocked. So it has a number of different functions. So you sometimes need to have myelin. So part of the repair process has been suggested that you need to repair the myelin that's been damaged after spinal cord injury. So a company here in the United States, specifically in California, called Geron, is proposing to do a trial where they will take these stem cells that are human stem cells that have been grown for many generations. These are called immortalized stem cells. In other words, they're going to transplant human stem cells from somebody else into your spinal cord. So they're not your cells, but they are human. Nevertheless, you will need to have some protection against these foreign cells, just like any kind of tissue transplant, whether it be a heart or something else. So we don't know, once again, the outcome of this particular trial, but hopefully they'll have an opportunity to get started in the not-too-distant future. Now, remember I talked about bone? Bone was that one success story in terms of cell transplantation. Well, people reasoned that, okay, look, we can get these stem cells, if we want to call them that. We tend to, in science, not want to call them that, but that's okay. We can take these early cells, and if they can make all the different kinds of bone cells, maybe they could make neurons. Okay? So somebody came up with this, and of course they tried it in cell culture, and they got it to work. So now there have been a lot of different approaches being proposed for the Czech Republic, Brazil, and India, where they've been taking these primordial progenitor cells from bone and making them into neurons and doing transplantation. Once again, no results, okay? Once again, they're doing controls, and they're gathering all the data. It's all coded data, and so we don't know the outcomes. We do know that it has some benefits in some of the animal models. All right, but what I'd like to complete this talk with you about is what we can do in terms of continued rehabilitation. And this is something that goes on lifelong. So there's all kinds of goals for rehabilitation training after spinal cord injury, and you can read this long list as well as I can. And for those of you who can't see it from where you're sitting, it's the same list that's on the handout. not only are we trying to improve various functions with rehabilitation, we're also trying to limit or reduce some of the detrimental aspects that can happen after spinal cord injury, including such things that I haven't talked about as yet, spasticity, pain, infections, pressure sores, anxiety, and depression. So these are all goals, very achievable goals for activity-dependent rehabilitation. And I also mentioned earlier on that we were going to talk about this phenomenon called plasticity. Okay, so who here likes kittens? Anybody not like kittens? Okay. Well, these really cruel scientists, way back when, who obviously didn't like kittens, put a patch over the eye of a kitten after it was born. So they made pirate kittens, okay? And then they asked themselves, much later on, what happened to the visual cortex? As you know, your eyes receive signals from the outside world. They send those signals into your brain. And indeed, there's a pattern of the way these cells from your eye project into the brain. And they set up these columns in the brain, and they're called ocular dominance columns. Now, I've just told you a Nobel Prize story in like 30 seconds. This is a brilliant discovery. It was the whole basis for understanding how the brain worked, and it comes from about 50 years ago. But the patch experiment showed something dramatically happened to this pattern of connections within the brain. And what happened was, those areas of the brain that normally received input from the right eye, which was now obscured by the black patch, they shrunk in size, or apparent size. And the inputs from the left eye, which were now dominant because there's nothing else coming in for the little kitten to see through except his left eye, they took over and became much more prominent within the cortex. And indeed, when they reversed this procedure, some of these green areas in this particular right eye projection expanded again. What it showed is that the functional connections from one part of the brain to another part weren't fixed. They weren't laid down like a roadway, like I-5. They were plastic, okay? They were like tracks in the sand. Once things come in like the water and washes over the sand, things change again. So this kind of plasticity was thought to only happen during development. And this is what we thought for decades. This was a developmental process. But more recently, we've discovered that yes, when you're young, you have an incredible amount of plasticity. And that's why children who have the misfortune of having a traumatic brain injury at very early ages recover remarkably well. I mean, it is scary how well they recover in comparison to an old guy like me. So, the question became, was it only a developmental process? And the answer turns out to be no. Plasticity occurs as a natural physiological process in all our brains all the time. It's the basis for your learning anything, including remembering anything of what I might say tonight. It's also the basis for any memory that you might have of what I look like, which you're probably trying to get out of your heads right away. So plasticity is fundamentally important to all of life, and indeed underlies virtually everything that you have recovered after traumatic brain injury or spinal cord injury. So if we take this little cartoon, you can see that I'm a graphic artist par excellence in this particular case. And here's my death to neurons, very graphically shown for you there. I can't draw a straight line with a ruler, actually. If it wasn't for PowerPoint, I'd be lost. So how could we get around this problem of an interrupted transmission between one neuron and the next? And by the way, this one neuron represents, hundreds of millions. So you'll just have to accept my point that I can't draw that many. Well, one possible way of recovering this process is to get those neurons that have been preserved, that haven't been damaged by the trauma or disease, to take over those functions. And indeed, we know that this kind of mechanism can occur in your brain. So you can have alterations in the way these preserved neurons now connect to other neurons in your brain. So this kind of plasticity can occur. We can set up detours so we can go around a damaged region by using local interneurons. So I want you to think back to the thumbnail and the little distal process. All we need to do is get around. After that, we can retrain those connections to do other things, to do other functions. That's the goal of plasticity. Yes, it's nice if we could get some regeneration and make everything the way it was before. However, it's not essential in terms of repair. Well, come on, not just smiles, a little clap for the graphic artist here. All right. Skilled use of hands is important. Now, I had to think long and hard. And I must admit, taking an example from the Seahawks, yeah, that might not be the most appropriate sports to choose for Seattle right now, but hey, we all have hopes, right? The Seahawks will once again return. But undoubtedly, this gentleman here, who's well known to anybody from Seattle, is somebody who had very skilled hands. And it's too bad that we don't have him with us anymore, but he sure could play a mean guitar. But skilled hands are important in everyday life. I think we'd all agree that the proper use of a knife is very important, and some skill has to be wielded, or otherwise we have consequences to suffer. And of course, we can go from the very practical to the ridiculous. But once again, we still have a need for very skilled hands. I have no idea where this picture came. Well, I know where the picture came from, but I have no idea where this guy lives. But that's one heck of a party trick, isn't it? I mean, you really would get people to stop drinking if you came in and did that. I mean, they just say, okay, I've had too much. All right, so a continuum of active rehabilitation is critical to recovery. So what I just said to you about plasticity, if you just think about it for a second, if we give you a drug that is going to promote repair, we have to use that repaired circuit. If we don't use something, we lose it. Mom was right. Use it or lose it. So as a consequence, rehabilitation is part of the cure, whether we use a drug, a cell transplant, or rehabilitation alone. You've got to have rehabilitation. So we've been working, for example, and I'm just going to show you a few examples of some of the stuff that I've been doing in the last year on arm and hand function. This particular robot that you're seeing this person in, this, by the way, is one of my colleagues. His name is Kip Kramer. And Kip has this robot which supports his upper arm, his lower arm. It has a little joystick which allows him to move in a variety of different wrist movements. And it also has a sensor in there that he can squeeze. And what Kip is engaging in here are a number of virtual reality tasks. That's games, is what my kids call them. And of course, being over 50, I'm a complete incompetent at anything that is thrown at me by Sony, Microsoft, or Nintendo. However, these games I can play. They're a little bit more simplified, and they are in various directions that are pushing specific hand and arm functions. The robot can provide varying levels of assistance in terms of anti-gravity support, etc. I'm not going to show you any data about those kinds of things. Suffice to say, I will tell you this, and it's unpublished, so that means, of course, it hasn't been peer-reviewed by people that actually know more about this than I do. This kind of technology has been effective for people even 4 or 5 years after spinal cord injury. Perhaps not as effective as it might be 4 or 5 months after spinal cord injury, but nevertheless, it's having benefits. I really like that sound. So rehabilitation is something that may be beneficial and effective even at very late stages after spinal cord injury, in something in a sense that is very much like any kind of exercise program. We can always benefit by continuous exercise. So here's another project that we've been involved with. And the reason I'm showing you this one is to talk to you a little bit about a very brilliant man, which is not me, but to emphasize we're now moving into a different realm of healthcare. It's called telehealth, and you've probably heard about this for years and probably not seen much evidence of it actually being put into actual activity, but it is coming, and it's going to come in a big way because it's cheap. And, you know, every HMO loves cheap. So that being the case, what we've been able to do is provide these various devices that are, once again, robots that can be taken home by the individual and used in their own home. They're connected through to a laptop computer, which allows the individual to go through a series of gaming exercises that, once again, specifically works on particular hand or arm functions with this instrumented device. We can run 4 patients simultaneously. Probably we could run more, but we don't have the capacity on one laptop screen to get any more than 4 people on it. We can run these things. We can see you doing the exercises. You can see us. And we can run 4 people anywhere in the world that we have a good internet connection. So you can do rehabilitation at home. So this is very important, especially when you have short stay in hospital after any sort of traumatic injury, where people are being discharged back into the community within a few weeks after their injury in many cases. And of course, in your community, there's often limited rehabilitation services. So if you could provide something from a central location anywhere in the state of Washington, I'm sure that would be a benefit to many people who've had a spinal cord injury. What is also coming, and it's not coming directed specifically for spinal cord injury, are a variety of new gaming controllers. This one is very familiar to all of you because it's very simple. 50-year-olds can use it, so I can use it. Of course, my kids still kick my butt when using it, but at least I can sort of stay in the game for a bit. So Nintendo has this kind of a device. It's very good for promoting, obviously, exercise. It's also good for some devices, or some, I should say, activities with regards to arm function. Microsoft is coming out with a new gesture-based technology where you only have to wave your hand and arm in front of a screen and you have virtual buttons. You've seen this kind of technology in movies. iRobot, a number of different movies use this kind of technology. It's now coming, and it's supposed to actually come this summer. These kinds of new controllers, virtual controllers, will allow all kinds of people with physical disabilities, regardless of that physical restriction, to participate more fully in an ongoing rehabilitation program and maintain not only their fitness, but perhaps improve their functional capacity. You've seen the Locomat, and people like Bruce have even built their own home version of a Locomat to continue their activities. Here's where we stand with a lot of rehabilitation efforts, and I don't want you to read all this now. The important point to understand is that we're coming into this new era of rehabilitation, and you probably don't think of this as research. And for the longest time, rehabilitation research wasn't done very rigorously, but it's now being done very rigorously, and there's a lot of unanswered questions about how we set up the best rehabilitation prescription for each type of physical disability. And it's going to take a little bit of effort, but it's with the collaboration of people like yourselves that we can get this done most effectively. And that's why we are constantly coming to you and saying, be our partner. Come on. Come participate in our study. Because we need your assistance. We need your help. We need your partnership if we're to bring about effective outcomes. And with that, I'd like to say thank you, and I'd be happy to answer any of your questions. Oh, sorry, Chuck, sorry.
What do you think is going on to make activity-based therapy? What's happening in the brain and the spinal cord?
So, probably didn't make that connection strong enough in terms that, but what Chuck is referring to is what is happening with all this activity-dependent effort on your half in terms of what's going on in your brain and spinal cord. We know that repetitive activity of any particular movement will actually promote plasticity within those neuronal circuits, those neurons that are activated by that movement or involved in that movement. So what Chuck's trying to get me to sort of say very clearly, thank you, because he knows the answer to this. This is a rhetorical question on Chuck's part. It's plasticity that's being driven by this activity. And therefore, the more you engage in something, the better you get at it. If you go and ask Kobe Bryant, how do you do what you do? The answer you will get back from Kobe, just like I've got from Wayne Gretzky, is, I don't know, I just do it. But they've practiced, and it becomes just unconscious for them in terms of what they can do with a basketball or a hockey puck or whatever the activity is. I mean, how many of you here would love to play a musical instrument the way some of the professionals play a music? Wouldn't we all, right? I mean, you watch somebody play guitar like Jimi Hendrix, and you say, how does he do that? I mean, first of all, the guitar's upside down and backwards. I mean, how does that work? But he has trained his brain through repetitive practice to remold the connections so that he can play the guitar as effectively as could be possibly imagined by somebody playing a guitar upside down and backwards. Does that answer your question, sir? Thanks. Thank you for bringing that up. Somebody else had a question. Yes, sir.
What are the possible benefits, if there are any, of aquatherapy?
Okay. So for those of you who didn't hear the question was aquatherapy. What are the possible benefits? Numbers of different things. Once again, it depends on what your goal is. The good thing about aquatherapy is that it provides some resistance. So if you're trying to walk or run in water or do something, it's giving you some resistance. Now that's another critical thing that we haven't talked about yet. If I get you to do this, okay, that's fine, that's one thing. But if I give you a little bit more resistance, if I put something in your hand like a weight, which adds resistance, now we start to build up strength. So in terms of recovery, aquatherapy is like all kinds of resistance training in terms of providing a little bit more resistance to your movement, which helps in terms of building up strength of that particular movement. Okay, now the limitation of aquatherapy is that you are buoyant, and therefore you're providing some resistance to movement in one direction, but you're providing assistance in the other. In other words, you're sort of going to become more buoyant, and therefore you have less resistance on your long bones. So in terms of, if you were to say to me, well, will aquatherapy by my running in the pool help my bone density? Yeah, it might, but if you could walk on land, that might be even better still. So once again, it's all a question of degree. Does that answer?
Thank you.
You're welcome. Yes?
Is there anything in the pipeline for osteoporosis in people with spinal cord injury?
Activity. Yeah, just what we were talking about, yeah. Activity is certainly important in terms of redeveloping bone density. A lot of the work that comes, a lot of the knowledge about bone mineral density, as we call it, comes from space. Okay? Yeah, I used to do a lot of stuff with NASA and the Russian Space Agency. Living in Canada, you can go both ways. Anyway, What they found with their astronauts, and this is kind of a fun story, is that, they sent them up in the space station, whether it be the Salyut space station or the U.S. space station, and they'd be up there for a few months, upwards of 6 months. A couple of the Russians were up there for, 12, 13 months. Chuck can talk to you more about their psychological health after that. But when they came back, they had a lot of bone loss, all right? They had a lot of muscle atrophy because they're in this sort of limited, quote unquote, almost, but not quite, zero gravity situation. And as a consequence, they lost a lot of bone density. So they went through massive retraining back here on Earth to recover that bone density. And they got some of it back. Through physical exercise, etc. The interesting thing is they never got all of it back. Isn't that strange? So, you go up there for 6 months, and they would lose, somewhere between 20 and 30% of their bone mineral density. They'd come back down to Earth, and they'd get in phenomenal shape, right? They just, and they'd go at it for 18 months, and they'd measure their bone density, and it was back up to 90%. So they'd recovered maybe 10%, half of it, but not all of it. They'd come back years later, and they'd still be down a bit. So it's very strange phenomenon what happens. Activity has benefits in terms of cardiovascular, respiratory, immune system, well-being, just general well-being. So there's lots of benefits, but in terms of actual movement of the legs, in terms of independent movement, those people that have sensory motor complete have not benefited by this directly in terms of improved walking function. What we're really trying to sort of focus on is what has been preserved after the trauma. If there is some function in the hip flexors, if there is some function at the knee, whatever functions are there, we can work with whatever has been preserved. Okay? So even though the person may be classified as technically sensory motor complete because they have a limited number of functions, if there is any movement apparent, we can work with that. Okay? So that's what we have to work with right now. Yes?
You said assistive locomotive. What about for people who've been injured like 15, 20 years?
Okay, so what I was talking about earlier just briefly, and like I said, there's some encouraging sort of results coming out of several different centers. There was this sort of conventional thought, once again, that was wrong, that if you had a spinal cord injury, your recovery was sort of limited to the first few months after your injury. But what we've been finding by bringing in people several years after injury is that we can set up rehabilitation programs for them where there is some residual function. And indeed, they can take off from that point and get better. So when you talk about windows, right, where is the opportunity for us to intervene and have some benefit? We used to think it was fairly limited, but with further study, we're learning that it is bigger and bigger in terms of its opportunity. So there may be no closing of that window. It may always be available.